It is a group of all electromagnetic radiations. So when all electromagnetic radiation or a group of electromagnetic radiation, we call that as electromagnetic spectrum. And what is the characteristic or what are electromagnetic radiation? So they have these properties. Number one, these are the properties of electromagnetic waves. Number one, they all are transverse. So when we say they are transverse, it means the vibration is perpendicular to the direction of the wave. So all these electromagnetic waves, the electromagnetic spectrum consists of electromagnetic waves, and all these electromagnetic waves are transverse in nature. They all travel with the same speed, which we also call the speed of a light, which is 3 exponent 8. So any electromagnetic radiation is there. It in a vacuum, they all have the same speed, which is called 300 million meter per second or 3 exponent 8. This is also represented by letter C. So letter C means the speed of the wave. So you can write 3 into 10 to the power 8 meter per second is equals to C. C means the speed of light or the speed of electromagnetic wave in air. Light is also electromagnetic, so that's why it's having a same speed. They all can travel through vacuum. So these are some characteristic or the properties of electromagnetic waves. They all are transverse. They all travel with the same speed in a vacuum, and they can all travel in vacuum. And what are the electromagnetic waves? The name of these electromagnetic waves? You don't have to learn the number, but you have to learn the order. So what happened? Some of the electromagnetic waves having a longer wavelength, and some of them are having a shorter wavelength. So when you compare this electromagnetic spectrum consists of, so how many electromagnetic waves are there? You have radio waves, microwaves, infrared, visible. Visible is a part which we can see. Ultraviolet, X-rays, and in the end, gamma. So these all are electromagnetic waves: radio, micro, infra, visible, ultraviolet, X-ray, and gamma. But the only part of this spectrum for which our eye is sensitive or we can see is the visible light. So we cannot see ultraviolet, we cannot see X-rays or gamma rays, infrared, microwave, or radio wave. The only part which our eye is sensitive is the visible. So all of what is why we call them as electromagnetic waves. Number one, they can travel through vacuum. They all have the same speed in vacuum, 3 exponent 8. And they all transfer energy, and they all are transverse, means the vibration are perpendicular to direction of wave. The only difference between these waves is the wavelength and frequency. You can see here for a radio wave, it's a longer wavelength. But for gamma, it's a shorter wavelength. But when you compare the frequency, frequency means number of vibration in 1 second. So you can see for radio waves, less waves or less vibration per second, but for same gamma, you will have more vibration in 1 second. So this is the order. So moving from radio waves to gamma rays, what we'll observe? We'll observe an increase in frequency. The frequency increase means the number of the vibration will get more. And moving from Gamma rays to radio waves, what we'll observe? We'll observe the wavelength increases. Wavelength means the distance between the two successive crests. So the distance between two successive crests in a radio wave will be more than the distance between the two successive crests in the gamma rays. And frequency and energy are directly proportional. Higher frequency of the wave means it carry more energy. So which radiation carry greater amount of energy when it travel through the space or a vacuum? Radio
Gamma.
waves or gamma?
Gamma.
Gamma is having the highest energy. That's why if a person is exposed to gamma, it can be harmful as compared to a person exposed to radio waves. Radio waves is having effect on the human body, but compared to gamma, it's having a low effect or low risk, or cannot damage the human cell easily as compared to that of gamma rays. So copy this part, the electromagnetic spectrum. You don't have to copy these numbers, the frequency and the wavelength number. If you want to learn, that's good, but that's not part of the syllabus. Like you don't have, they will not ask state the frequency of ultraviolet, or they will not ask this. Copy this one. But it's not difficult to memorize. You can see it's a multiple of 3. Like 3 is 6, 9, 12, 15, 18, 21. Same thing, 3. This is 10 power, basically 1 meter or 10 power 1, 10 power 0, you can say. 1 into 10 power 0. Then -3, -6, -9, and -12.
Done, sir.
Okay. So in exam, you should learn this in order. Like order is also important. So you have to learn radio, micro, infra, visible, ultraviolet, X-ray, gamma, or other way around. You can start with gamma, X-rays, ultraviolet, visible, infra, micro, and radio. The second part of this topic, they normally ask the applications of these radiations, means where we use these radiations, such as, like example, you have radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma. So first, uses of these electromagnetic waves or radiation. Radio waves. So radio waves, normally it is used for land communication or terrestrial communication. Example, if this is the earth, the earth is having its own atmosphere. Like we have troposphere, stratosphere, mesosphere, ionosphere, and thermosphere, like the atmosphere, the whole atmosphere of the earth. And in this atmosphere of the earth, if we want to communicate, like example, we want to transfer the signals, radio signals, from one place to another. So for this purpose, we use the radio transmitters. So what these radio transmitter will do, Because radio wave is having a longer wavelength. So longer wavelength can be reflected back from the Earth atmosphere. So when this wavelength strike the Earth ionospheric layer, it bounces back and received by the observer. Or you can also send this directly from one place to another. So the advantage of using these radio waves, because these radio waves can be reflected back by the Earth atmosphere, it cannot leave the Earth atmosphere due to its longer wavelength. So when this radio signal strike the Earth atmosphere, bounce back and a person can receive. But the problem with using these radio waves, you cannot communicate too far or come in. Like example, if we are at position A and we want to communicate to position B, so we can use a radio wave. We can send it directly or we can send to the atmosphere. It will bounce back. But what if another receiver is there at position C? So if another receiver is there at position C, so you cannot communicate. It will be difficult to communicate to position C. Why? Because even if I send the signal, this signal cannot be reflected to that position easily. And when the radio waves travel through the atmosphere, the intensity of these radio waves decreases. That's why, like example, if you are living in Bureda, so if you tune in to any radio station in Bureda, for example, at a frequency of 100 megahertz, if you travel to Riyadh and you try to tune the same radio station at a frequency of 100 megahertz, you will receive another signal. You will not receive the same radio signals because these radio waves cannot travel through a long distance. Our atmosphere also absorb these radiations or radio waves. So it is for a short distance communication, but because it is less harmful to the environment and if less harmful for the human beings as well, that's why it is still used. So these are the boosters. You can see the satellite or the boosters which are used for radio communication. Yes,
Sir,
Hashim.
how to control the direction of the radio waves?
How to control the direction? The radio waves are produced by radio transmitter, and these radio transmitter are having a known as a hollow tube. This hollow tube is used to direct or decide the direction of the radio waves. Like there is a part or a component in the transmitter, but normally, for example, if there is a radio transmitter, if this is a radio transmitter, it tend to give out radiation in all the directions. It's not like specifically in one way. The radio transmitter is emitting out in all the directions. Is it clear? The idea, the radio waves are the lowest frequency and the highest wavelength and it is used mainly for radio and television communication. But for sky communication, we use microwaves. Why we use microwaves? Like example, and for communication of the microwave, we need a satellite for this. So this is the Earth. And this is the atmosphere of the Earth. So this is the atmosphere of the Earth. What happens if we have a radio transmitter or if we have a microwave transmitter? These mobile signals, we use microwaves. So what happens, like example, there's a transmitter at position A. Microwaves having a shorter wavelength as compared to radio waves. So these microwaves are not able to bounce back from the atmosphere. They can leave the Earth atmosphere easily. So as it leaves the Earth atmosphere easily, for this, what we need, for this communication, what we need a satellite. So what this satellite will do, like example, if you are at position A and you want to make a call to a person at position B. So what happened, how it is communicated? By using a satellite, basically each mobile is acting like, mobile phone itself is a receiver of the microwave as well as the transmitter of the microwave. So what happened when a person at position A makes a call? So means he generated the electromagnetic signal. That electromagnetic signal travel to the mobile communication. Like example, if you are using any mobile communication device or the company which is supplying you the service, that will transfer the electromagnetic signal to satellite. Then this satellite will coordinate with another satellite, and this will locate your position and you will receive the electromagnetic radiation. But this is use of microwaves. Why we don't use a radio waves? Because radio waves cannot pass through the earth atmosphere. It bounces back from the earth atmosphere. So for a sky communication, if you want to do communication through a satellite, we use microwaves. Is it clear, the concept of the microwaves?
Yes, sir.
And microwaves also, there's another use of the microwaves, as you have heard, like microwaves oven. So these microwave ovens can be used to warm the food. How it can be used to warm the food? Because what happened, our food contain water molecules. So any kind of food is there, there is water molecule. There are water molecules. So what happened when we send inside the microwave oven, when we use these microwaves, so these microwaves are absorbed by the water molecules. When these water molecules absorb, they start to vibrate and move faster. So as these water molecules move faster, their kinetic energy increase. As something kinetic energy increase, the temperature will also increase. That is why the food will become warm, as the water molecules are absorbing the moisture. Water molecules are absorbing the microwave, and it increases the kinetic energy of the water molecule. So we can use microwaves. We can use these microwaves for sky communication, and we can also use these microwaves for to warm the food. That is why you will find at a petrol station, at a petrol pump or a gas station, they mention do not or switch off your mobile or do not use your mobile. What is the reason why you should not use your mobile while refueling? Because what happened, your mobile is continuously sending the signals, okay? But when you're making a call or when you're using your mobile, the signal intensity is too high from your mobile. And that signal intensity, that signal will cause the molecules in the petrol to vibrate faster. When these molecules will vibrate faster, it might produce a spark. And if there's a spark, that petrol is a flammable liquid, it can catch fire. So it is dangerous to use mobile phones when you are refueling or at a gas station. Yes, any question? Is it
Sir,
clear?
please can you
Yes.
explain again?
What?
Can you explain again, please?
Okay. So microwave, which part? The whole part, or you want about the food? This part.
The whole part.
Okay. Look, this is the Earth. This is a Earth is having like a layer of atmospheric layer is there, troposphere, stratosphere, mesosphere, ionosphere. So if, for example, you are at position A how you use a microwave for communication, or how you're using the satellite or dish to receive some television signals as well. So what happened, you're at position A, you produce a microwave, example, you make a call, you're using your mobile, so your mobile is actually a transmitter of the microwave and receiver as well. And you want to make a call to a person which is at position B. Directly, if you are using a radio waves for the communication, because radio waves are longer, having a longer wavelength, so when they strike the atmosphere, they return back. So you cannot cover a greater space for communication when you are using a radio waves. That's why you use microwaves. So when you use these microwaves, microwaves are having a shorter wavelength and higher frequency. So as they have a shorter wavelength and higher frequency, so they are able to pass through our atmosphere. As they're able to pass through our atmosphere, how they are sent it back to the earth by the satellites. Earth is covered, like there are a lot of satellites which are covering the earth. So what happened, this satellite will receive and it will transmit this, like it locate, identify the position and transmit this signal to, it can send the signal directly to earth, or it can also use another satellite to communicate. It can send a signal if a person, like example, at position B was here and this was position C, so this satellite can transfer electromagnetic waves and a person who's at position B will receive those electromagnetic waves. But if you want to communicate to a person at position C, so then this satellite will redirect the signals, which is absorbed by another, taken by another satellite, and then it will transmit to position C. So for this communication, because the microwaves are not affected by the Earth atmosphere, are not absorbed much by Earth atmosphere or reflected due to Earth atmosphere, so we use satellite for this communications. And in case of food, what happened, like when we are using a microwave oven, so when you are using a microwave oven to warm the food, the food contain particles, mostly water molecules. So what happened when we send the microwave within the microwave oven? So what these particles absorb microwave and they start to vibrate. As these particles start to vibrate, so what will happen? It increases the kinetic energy of the particle. When kinetic energy increases, it means the temperature of the substance will also increase. So the substance will become warm. That's why, for example, if you set the timer for a microwave oven for 30 seconds, in 30 seconds it will deliver small amount of radiation. But in a 1 minute or 2 minute or 3 minute timer, it will give in greater amount of radiation. So the temperature of the food will be much higher. Is it clear? The concept of the microwaves?
Yes, sir. Thank you.
Okay. So microwaves are used for satellite television and phones, satellite television, not the normal antenna television. A beam of microwave is sent, like that's how you communicate, like what happened. This is a ground station or a TV station is there. This is sending the signal to satellite and the satellite will send it back. And a person, like if you have this dish antenna, you can receive those electromagnetic radiation. Is it clear? So related to exam point of view, you have to learn the uses for each of these radiations. Then infrared radiations are also known as heat radiation. So what happened for these infrared radiation, where we use your remote control you can do this as an experiment now, like take a remote control for your air condition, a split air condition, or even for your television. Like example, this is a remote control which is having buttons. And you can see in front of your remote control, there is a small source is there. It appeared to be a small LED, light emitting diode, but it's not LED. So you can see this small source in front of your television remote or any other remote. So when you press the button, so the moment you press the button, what it create a heat radiation or infrared radiation. And when it create an infrared radiation, your television is having a receiver which can record these infrared radiation. So when the television record those infrared radiation or heat radiation, so if I change the channel, or if I use the volume control, so I can do, or I can press a certain button, it produces because infrared radiation is also having a range, so it produces a specific infrared radiation which will command the television to do a specific task. How you can identify this? You can do a simple experiment to see, because with our eye we cannot see the, when you're pressing a button you don't see any light or any radiation coming out, because our eye is not sensitive, our eye cannot detect infrared radiation. So what you can do, you can just switch on your camera, the mobile camera, and place remote control in front of that mobile camera and press the button. So the moment when you press the button, you are able to see the light. With naked eye, it's not you are not able to record any infrared radiation because our eye is not sensitive to this radiation or wavelength and frequency. But you can identify, how you can identify, you can just use a mobile phone cameras can record the infrared radiation as well. So just open your or use your mobile camera and press the button of on the remote control, and you will see the radiations or rays are coming out. This you can try. If you have now, you can try now, otherwise you can try later. Second thing, it can also be used as for intruder or burglar alarm. How it can be used, like example, so this is the contain electromagnetic radiations. You cannot see the electromagnetic radiation. This is just to explain the idea that what happened. For example, if someone is crossing this part, our body is blocking the light. So the moment when our body block the light, block the infrared radiation, or change the amount of infrared radiation, then this alarm will work. So it can be used for intruder alarms as well. So infrared radiation is used in a household, electrical appliances, television control, and intruder alarms as well. Then the only part of electromagnetic radiation which is visible to us is a light. And this light, actually, we also call this as a white light, which include violet, indigo, blue, green, yellow, orange, and red, Vibgyor. In this Vibgyor, violet is having the highest frequency when we compare these radiation. So violet is having the highest frequency and the shortest wavelength. And red is having the shortest frequency and the highest wavelength. That is why you will find The colors which are used in a traffic signals. So what are the colors in a traffic signal or a traffic light used? So you use red. So the colors which are used, there's a red color, orange or yellow is there, and then green is there. So what is the reason why specifically they choose these colors? Why not any other color? In the all are visible to us, but specifically violet, instead of violet, indigo, blue, red, orange, yellow, or green is there. So there is a physics behind it. Reason for that, red is having a longer wavelength. So as the red is having a longer wavelength, so far away from the signal, you can easily detect or identify the red color. Because of its longer wavelength, it's easy to recognize or identify the red color. If it was violet and indigo, when you will reach closer to the signal, then your eye can recognize, because its red color is having a low energy as compared to that of violet or indigo. Our eye is sensitive to all these colors, but it can easily identify or detect red color rather than a violet or a indigo light, or a blue light. That's why a traffic signals, you will find for stop, they use this red light. And then after red, we have orange or yellow, and you will find then orange or yellow is there. It's for caution or attention. And then green is there because green is used for a short time. That's why they use this green, these colors. Is it clear the idea why there's a red light used for, or these colors are used for traffic lights? Our eye is sensitive to all, but red is having the longer wavelength, so it's easy to recognize or identify far away from the signal or the source or transmitter. So visible light, the light for which our eye is sensitive. There are many uses for these visible light we can use for observation. These are optical fiber or fiber optics. Very thin. These are many fiber. It's not one optical fiber. It's having many fiber optics, like it's a bundle. Basically what happened in optical fiber, we took this part, that what happened, the light will undergo total internal reflection. So when the light enter from one side, it will undergo total internal reflection, and eventually it reach the other side. So we are able to send the information or a data in the form of light from one place to another. Or it can also be used for endoscopy. Endoscopy means, for example, if a doctor want to examine esophagus, so how he can examine the esophagus, he can use this technique of endoscopy. Or if you want to find or identify or examine the stomach, so endoscopy can be used. How this endoscopy can be used? So they use bundles of optical fiber, and they pass the light, because you don't have any light source inside your stomach. So they send the light. So when this light will strike, which will undergo total refraction, and it will bounce back from the walls of the stomach, inner wall. So we receive the signal back. So as we receive the signal back, so we can have a image of inside stomach. This is how the endoscopy is done. Is it clear? The uses of the visible light. Any doubt in this?